Good evening, students. Today, we are looking at another fiber. Last week, we discussed about cotton as a seed fiber. So this week, we are discussing about flax as a stem fiber or bast fiber. So if I talk of stem, so the name means stem. So the stem of the plant. So the plant, we have seed. So you have seed fiber. Example is cotton. Then you have leaf fiber. Example is sisal. Then today we are discussing about the stem. An example, we have the flax. And the fabric we get from flax is called linen or lin. Okay. So flax is the source of linen fabric, and it is a versatile crop that can be grown in a variety of climates throughout the world. So its scientific name is Linium usitatissimum, translated as linen most beautiful, rightly describe this vitality. So flax is one of the oldest textile fibers and known to be the first woven and spun vegetable fiber. The art of weaving flax was so advanced in ancient Rome that wearing linen cloth was considered to be a sign of aristocracy and gleaming whiteness of linen as a symbol of purity. So, in fact, the word candidate used for office seekers has its origin from Latin word candidus, which means white linen. So, people thought that bright white linen was a sign of being pure and special. So when someone wanted to become a leader, they wore white linen clothes to show they are honest and good. So the word candidate, which means someone who wants to be chosen for an important job, actually comes from the Latin word, that is the candidus, and which means white linen, very pure, original. So this is the plant of the flax fiber. So the flax plant is here. So this is the stem that I'm talking about. So it's a stem fiber. So these are the stems. So the stems here, you're not going to use the flowers or the leaves, but the stem. You need to take off all the flowers and the leaves. Then we use the stem to process into or to get our fibers. So the same thing applies to this one. Okay, so later you watch this video. I'll put it on the platform for you to watch it. Because here, if I play it, it will not come. The voice will not come. So I'll put it on the platform for you. Okay. So let's look at harvesting of all the processes that one need to go through before we get the flax fibers. So the first is harvesting. And harvesting of the flax is by pulling. So we pull flax plants with the roots intact from the soil. So instead of cutting them at the base. So this enhances the fiber quality. So by preserving the valuable fibers running from the stalk to the roots so that nothing is left. This method increases fiber length. Additionally, it prevents sap leakage, pre- uh, preserving fiber moisture from better quality or for better quality fabric. So when you cut, a whole lot is left in the soil, so you don't cut. And when you cut to the fluid that comes, disturb the color permanently. So it's not advisable to cut, but rather you pull from the soil. So the first process is called pulling. That is, harvesting is by pulling. So after pulling, we do what is called rippling. And what is rippling? So flat stalks are allowed to dry in the open air before undergoing thrashing. So hand thrashing involves beating the dry stalks to crush seed pods and shaking out the seed. So we need to shake the seeds, take away all the leaves, everything remaining the stalk, because that is our focus. So after getting the stalks, we need to ferment the stock so that we can get the fibers. You see, when you want to take away the back, the skin of the plant, it's very difficult. It will break. So to be able to get it, you are supposed to ferment it to become sticky. So the art of fermenting is allowing you to rot a little. It's called retting. So retting is a method used to loosen the fibers for separating bark from the stalk. So by rotting the inner woody core, it allows the soft outer fibers to be freed from spinning, or to be freed for spinning. So we have types of spinning, types of retting. We have the dam retting, pool retting, pit or stream retting, where we put the bundles of the stalks along the riverside for some time. So as the river flows, it will wet the stalks to be softened. So you have dew retting. Dew retting is where we leave the stalks, the bundle of the stalks in the open for rain, dew, and sun to react on them for about 3 weeks. Then we halt. We continue with the process. We have tank retting. Tank retting is where we put them in tanks with water to speed up the process. And then you have the chemical retting. You put them in tanks with the water, then you add chemicals. This one is very fast, but the fiber quality is very low. So after retting, now the fiber, uh, the woody core and that of the skin becomes somehow sticky, so we can break it to get our fibers. We break the woody core, that is the wood, because now we don't need it. So we subject the stock to breaking. So breaking, this is where fibers are separated from the stalks by completely smashing the woody core into tiny fragments. So after that, what next? We need to take away all the woody core because we don't need the wood. We need just the skin. So scratching is the next process. So scratching is the process of scraping a small wooden knife down the length of hanging fibers to remove broken woody bits. Alternatively, fibers can be passed through fluted rollers to break up the stem, and agitation removes the woody parts. So after scratching, our next process in flax is called hackling. So here, the rippling, you can subject the rippling like ginning, right? Okay, then the hackling here, we can also liken the hackling to harden in cotton. Hackling and carding in cotton. So these operations separate the fiber bundles that are still clinging together and remove shorter fibers by drawing the fiber through series of combs. This is done with at least 3 different flax combs or hackles consisting of a board with steel spikes and needles. So this board that have let's say needles on them, we just uh, brush the stalks on them, taking away. So when you do that, all the woody core, all the impurities, and their impurities, all the impurities will fall down. then you get your fibers. So this one is very short. So after that, we have our fibers. So the next process is called the spinning. So during the hacking process, you need to align the fibers aligned to one another, that in a parallel position. In a parallel position. So after that, we twist them. So the twisting is the final process, and that is called spinning. So spinning is where strands of fiber or fibers are twisted together to make yarns, which are then wound onto bobbin or spools. So after that, we have our long yarns. So to make them handy, then we need to package them. So we package them just like cotton, some into cheeses, some into cones, some into hanks and bobbins. Okay, so these are the processes to get the yarns. Now, let's look at the physical properties of the flax fiber. So the flax fiber is very strong. That is the tensile strength. It's very strong fiber. And it has a tenacity of 5.5 to 6.5 grams per darnel. The strength is greater than cotton fiber. It means that flax is very strong. Flax is a very strong fiber. So elongation at break. So linen does not stress easily. Inelastic. It has an elongation at break that is between 2.7 to 3.5. If you stretch it, it will break. Okay. So the color is yellowish to gray. That is the color that you can see. The length is between 18 to 30 inches. And flax is very lustrous fiber. That is, it shines. So it brightens. It's not like cotton. Cotton is a very dull fabric, but cotton becomes lustrous when we add when we mesterize it. So after mercerization, cotton becomes lustrous, but flax is very lustrous. It is brighter than cotton fiber, and it is slightly silky. Okay, so elastic recovery. Linen fiber has not enough elastic recovery properties, just like that of cotton. So that is the comparison. Specific gravity is about 1.50. The moisture regain, the standard moisture regain of flax is 10 to 12%. And its resiliency is very poor. It's very poor, has poor resiliency. That's ability to bounce back. It's very hot. It's very poor. Effect of heat. Linen has an excellent resistance to degradation by heat. So it is less affected than cotton fiber by heat. The effect of sunlight. Linen fiber is not affected by the sunlight as other fibers. It has enough ability to protect the sun. So let's look at the chemical properties of the flax fiber. Effect of acid. Linen fiber is damaged by highly densified acid, but low dense acid does not affect if it is washed instantly by application of acid. So they are from the plant family. So they are not friendly to acid, but they are friendly to alkalines. Okay, so effect of alkaline. Linen has an excellent resistance to alkalines. So it is not affected by strong alkalines. So when you want to process cotton, it is flax, it is best to use alkaline or base chemicals. Effect of bleaching agents. Cool chlorine and hypochlorine bleaching agent does not affect the linen fiber properties. And the effect of organic solvent. Linen fiber has high resistance to normal cleaning solvent. So you can use a whole lot of soap, different types of soap to wash it. Okay, microorganisms like fungi and bacteria can harm linen fibers because they are coming from the plant family. Mildew, in particular, feed on linen fabric, forcing it to rot and weaken, especially in hot and humid conditions. However, linen can be protected by treating it with certain chemicals like copper and naphthalate. Naphthalates. Okay. Effects of insects. Linen fibers are not attacked by most beetles, so dyeing is generally challenging because it's lustrous. So the luster means that you have a lot of what waxes inside. So that will resist the penetration of the dye. So the major uses of the linen fabric is mostly for dresses, suits, jackets, and so forth. Okay, or many others. So I have given this project to you already. So next topic is blends and mixtures. And that one you will handle it. But before blends and mixtures, I need to discuss the animal fibers. So our next presentation will be on animal fibers. Thank you.